I'm going to address Sessionee's question first. She was asking about when you have a one to graph, then she had some trouble getting the graph to work for her. So if you have a problem like y equals x squared plus 2, let's say, then right before you do the graph, you should just look at the equation, and it may say f of x. Now that we're in functions, it may say that. And the y equals x squared plus 2, you need to know, because this is squared, that that is going to curve. And what that makes is, when it curves, is a parabola. This parabola is scooted up to. This is a shift up to because it's on the outside. So this vertex that used to be at 0, 0 has now scooted up, and it's at 2. So it's scooted up till 2. So you know that that is where that should be. But over here on the little tools, there's a little tool over here on tools, and you have to select that tool before it will graph that a parabola. And you can try all you want to. If you've not selected the right tool, it won't graph that parabola. So when you put in your ordered pairs, let's try some negatives, because I think some people are having trouble squaring some negative ones. So if you put in -1 and square it plus 2, you'll have -1 times -1, which is +1 plus 2. So that will be at the point 3. 1 plus 2 is 3. So -1 would be up at 3. +1 will do the same thing. Y equals 1 squared plus 2, and that's 1 plus 2, which is again 3. So over here on the positive side, reflecting across that y-axis, you have another point that's at 3. And once you get those points in there, then the parabola will take its shape. Until you get a couple of these in there, you'll see this little graph that looks like a T, a big T. And you can move it around until you put it right here on this one. And then it's going to look like this as you move to try to put in another point. And once you get this other point, if you have selected this tool, it'll probably give you your parabola. If not, then go in and put a third point somewhere, and for sure then it will give you a parabola. I think on that little tool it has 3 little dots, so you're going to need 3 places to put in a point. Now, if you have y equals the absolute value, let's put a negative in front of it, negative the absolute value of x minus 3, then right off, before you know anything, you should know that that's going to make v. It's v because it's absolute value. Absolute values are v graphs. So when you go over there to pick your tool, you're going to have to pick the tool that says v, that has a little v. Now, this one in particular is going to be upside down, because this minus is going to make it upside down. And this 3 sticking out on the end is going to shift it down 3. And when I say it, I mean the vertex. This little vertex right here that's normally at 0, 0 is going to shift down to 3. So 1, 2, 3. It's going to shift down, and then this absolute value is going to flip upside down because of that negative in the front. So once you get that in mind, and you know to pick the tool that says absolute value, then you'll need to put in some points. And let's put in 1, and that would be y equals negative the absolute value of 1 minus 3. And the absolute value of 1 is how far it is from 1 to 0 on the number line. So that would be a distance of 1. So this negative stays there, but the absolute value of 1 is a positive 1 minus 3. Now you have -1 minus 1, which is a -4. This is going to be 1, -4. If you put in something like -1, then you're going to have y equals the negative of -1 minus 3. -1, the absolute value of that is how far is it from -1 to 0 on the number line. It's a distance of 1. So this value right here will become 1, but that negative stays there. It can't be affected by this. It's not like whenever you have a parentheses and you can multiply that. You can't do that on absolute values. So this would be -1 minus 3, which is -4. So what's going to happen is at 1 and -1, I get a point down here at -4. And when, again, you're going to get that little cross thing when you're trying to put these points in here. I like to put my vertex point in first because I can identify kind of where that is. But if I didn't know that, I could put in a 0. And then when I put a 0 in, the negative of 0 is still 0. 0 minus 3 is -3. And that would give you that point. You can also graph it on your calculator, but remember to use that absolute value key. And you can see and get some points off of your calculator to get your absolute value graph. Okay? Any questions on how to do those graphs? You'll have a parabola, you'll have an absolute value, you'll have a cubic. Cubics look like that. And cubic is when you have something to the third power. So you'll have those. And then you'll have lines. There's lines. There's a line graph as well. That's y equals x plus or minus something probably. So those are the 4 kind that we've really talked about a lot. We've also talked about rational ones, and we're going to talk some more about those. But let's just talk about domains, since that's one of the things we talked about last time for these. What is the domain for every one of these kinds of function graphs? The line, the parabola, the cubic, and the absolute value. What is the domain?
Your x
All real numbers.
All real numbers. The only one that doesn't have all real numbers is which one?
Fractional.
The fraction one, and those are called rational functions. So all of these kind, and now that we're in domain, you will know that all of these have a domain of all real numbers. Okay? Let's review a couple of other things that was in the support section. We have a problem. I think this is the one that may have had a wrong answer, but I'm going to go over how to do it, and we'll see what happened on it. This is a problem that has these 2 negatives together like that, and notice this one is a parentheses. It's not an absolute value. So when you have those 2 negatives together, remember it's like a -1 here multiplied by that, but when you have those 2 negatives together, what does it make?
A positive.
A positive.
Positive.
So this would be -6/5 plus 2/15. It's what that ends up being there, because those 2 negatives will make a positive. Now, you have to have a common denominator in order to add fractions. So you need something. We talked about this last time. Remember that you want the larger number, not the smaller number. So I need something that 5 and 15 would go into. What would it be?
15.
15. So if I want 15, then how many times will 5 go into 15?
3.
So I would have to multiply this number by 3/3. That's called need over need, actually. That's what I need to multiply there, 3/3, to get my 15. So I would have -18 on the top and 15 on the bottom when I multiply 5 times 3, because I'm trying to get a common denominator. Now, I already have 15 over here, but if you really want to multiply by something, you could multiply by 1, because 15 will go into 15 1 times. Now, 2 times 1 is 2, so see, this one has not changed. But now I can combine the numerators because my denominators are like. So I have a -18 and a +2. Because the signs are different, I would subtract, and I get negative 16/15. And somewhere in your lifetime, you change that to a mixed number of 1, -1, and 1/15. But in college algebra, we don't change to mixed numbers. We leave them as improper fractions. So you want to leave that alone. Okay, maybe it was Eric that asked that question. Maybe I'm remembering right. Was it you, Eric?
Yeah, that's right.
Okay, now, did you decide that that answer they gave you was really wrong, or did we have the wrong problem?
Actually, no, that's not the right one. The one that I sent you is multiplication.
A multiplication one. Okay, well, maybe that was the problem. Maybe it was a multiplication one. If you can get that for me in a minute, you know where it is? Did you write it down anywhere? We'll go over.
I know exactly where to find it. We can revisit this in like a minute or two after you go over another problem, or we
Yes,
can.
yes. I'm going to
Okay.
go over some of the others that people had trouble with first. And then when I get to the end of this, I'll ask you about that, okay? Remind me if I don't remember.
Sounds good.
This one is graph A plus 3 is less than or equal to negative 11. We covered this last time, but I noticed that even the ones that got good grades, if they missed one, they missed one of these that I'm about to show you. So I want to go back over them again so that maybe you can catch what happened on it. This is graph, one of those linear graphs, and so you solve it first. And you get A is less than or equal to negative 14. Well, if I wanted to write it in set notation, which is sometimes they ask for, then I just write it with these little squiggle lines called braces. And then you write A such that, remember this up and down one is such that A is less than or equal to negative 14. Then the next thing you want to do is put it on a graph. So if I put this on a graph, my 0 would be over here somewhere. And I noticed that on the one that they had on the Milo Math Labs, they had negative 15 here. And they had started their little graph right here. So you were just supposed to know that it was before negative 15. And then I used a bracket, and I think two of the people I looked at that missed this had put a parentheses instead of a bracket. You use a bracket if it has that less than or equal to. This equal to sign underneath here makes you have a bracket. If it's just less than, you will have a parentheses. But if it has this equal to bar underneath your inequality, then it'll make a bracket at your border or your boundary. So that's the way the graph should look. Then interval notation we talked about last time, you have to go left to right. If I came into this graph from left to right, I would be coming in from negative infinity all the way up to negative 14, and then I would put my little bracket. They didn't actually put negative 14, but they had started their graph 1 over. So you were supposed to know that that was negative 14. Okay, any questions on that problem? Okay, let's do this one. 4/7 x equals negative 1/14. This is one of those where you've got to have a common denominator because your denominators are different. So something that 7 and 14 would have common would be, think larger. What would it be?
14.
14. So I take 14 and I multiply it by both sides. Cancel that 7 into that 14 goes 2 times. 4 times 2 is 8. And on this side, I have that x. Over here, my 14s will cancel, and I have negative 1. Now I have to divide by 8. So x is negative 1/8. So be careful on those fractions. This one was missed. It says negative x over 2 equals 11. There's no denominator underneath that 11 except for one that's understood. So what I want to do is use my denominator and multiply both sides of this by 2. That will cancel out that 2. And I'll have negative x equals 22. But you can't leave it as negative x. You can only have these equations have positive x there. So you have to take one more step and divide out that negative, and you have x equals negative 22. So don't forget to do that. Okay, another one that was missed was negative 5x is greater than or equal to 3.0. This is one that has that rule for, I'm sorry?
This question drove me insane. I did 3 attempts and missed it, and I did like similar question.
In this problem, you're using that rule that says if you divide or multiply by a negative number, it will reduce the direction of your inequality. I've got to get rid of that negative 5. It's multiplied by x, so I divide both sides by negative 5. And so that would cancel the negatives and the 5 and leave me with x. It's going to reverse that to less than, and I've got to figure out what this is. 5 into 3.0. So if I put my 0 up here, and 5 will go into 3 0 times, and then 0 times 5 is 0, and so you have 30 when you bring it down. Now you divide 5 into 30 would go 6 times. 6 times 5 is 30, and you have a 0 remainder. So this answer is 0.6, but because it has a negative 5, a positive divided by a negative would make a negative 0.6.
And I got it wrong because I thought I had to put it in fraction form.
Oh.
I didn't know I had a decimal for this question. That's what kind of
Did you
got
put
me.
6/10?
No, I don't even remember what I put. I might have it on a scratch paper somewhere, but I ended up doing a similar question and getting it right. I wasn't the inequality part that messed me up. It was the decimal that did.
Oh. Well, I would think
I divided 3.0 by 6. I didn't even try to do long division. I got greater than equal to 1/2.
Oh, okay. Well, 1/2. If that had been a 6 down there, it would have been a 0.5. So then you'd have been good. But
No, that was the similar question that I had where like it gives you a different style.
I would think they would take a fractional answer for that. And this fractional answer for 6/10 is 3/5. I would think they would take 3/5, but I don't know. They might not.
Yeah.
Pretty picky.
I have it right here, 3/5. I wrote 3/5. That's right, and it worked. I did a similar question. I was like, oh, I guess I want a decimal. So I did a decimal for the second one and I got it. But I was so frustrated because I did have the right answer.
Well, you weren't the only one that was frustrated. Did anyone else have a question about this one? Because I know that there were several people that missed it.
You know how to switch your fractions to decimal on your calculator?
Is that Luke? Is that Luke saying that?
I was just asking her.
Luke, do you want to tell how to do it? I'll show you. So if you have 0.6, okay, and you want to change that to a fraction, there's a little math key that's down here. See that math key?
Mm-hmm.
Get that math key. That first one says fraction, and you can enter, and it's telling you, do you want your answer to go to a fraction? And yes, you do. So you enter again, and it will give you your answer of 3/5. Okay.
So on the test, will it like specify if they want a fraction or decimal answer? Or?
No, it will not. But I will go through and check.
Okay.
I always do on the test. I go through and check to see if there is an equivalent answer that you've given that they've counted wrong, and I correct that.
Okay.
So I will go through and check them. I always do, just to make sure there's not something like that that's happened, because that's a good answer. It's just not the answer they wanted.
Yeah.
For me, every time the problem is in decimal, I'll do decimal. If it's in fraction, I'll just do fraction.
That's a good rule to follow. Okay. All right, let's look at another that several people missed. We had x such that -2 is less than or equal to x is less than 2. This is the one that's at betweenness. See how the x is in between -2 and 2, and these are both less than symbols, so we're good there. And they wanted you to graph it. So on the graph, if you put a 0 and some -2 and some +2, your x's that you want are in the middle here. And this really says that our x is bigger than -2, but less than 2 at the same time. So because this one that's associated with this side has this bar underneath it, this is the one that you want to do the bracket on. Some people got that mixed up. Because this one is associated with that 2 on this side, this is the one you put a parentheses on. And then your graph is in between there. Now, if you want to change that to interval notation, it starts at -2 with a bracket and it goes to +2 with a parentheses. Okay. All right. They had another one on your assignment that was backwards. It was x such that -1 is greater than x is greater than -3. Those are greater than symbols there in that between us problem, and they're not supposed to be. So you have to switch it. It's like picking the whole thing up and moving it around to the other side. So that -3 comes on this side, that -1 comes over here on this side. Those become less thans, and the x is in between. That's the way that's going to look. You can't use greater thans in a between us problem. So now for your graph, you have a -3. If I let this be 0, I have a -3 and I have a -1. They're both less than symbols. So at these borders here, I want to use parentheses, and my set goes in between them. To do interval notation, it would be -3, comma, -1. Got it? Okay.
Oh, hold on. I was trying to copy that.
Okay, I'll wait. Okay, this is one that a lot of people missed, and I think it was because the x was on the wrong side. See how the x is on the right side? That's a problem for a lot of people. So it's okay if it's an equation. It's not okay if it's an inequality. You want it to be on the left side if it's an inequality, and I'll show you how to move that in just a minute. But you want to add the 3 to both sides. So on this one, you would have gotten a -26, almost subtracted incorrectly there, equals to x. But that's how you get rid of the number that's with the letter if the letter happens to be on the right side. Okay, let's talk about one that's in an inequality, and we had, oh goodness, seven or eight people that missed this problem.
I'm sorry, can you go back to the last one?
Uh-huh. Do you have a question about it?
I was just trying to make sure I got it right. Okay.
Okay. Did you get it right?
Yeah, I got it.
Okay. This is an inequality. On inequalities, you want the variable on the left. Doesn't matter on equations, but on inequalities, it does make a difference. Now, normally most of you, in fact, most of you did, subtracted 7y from both sides. And you can get away with doing that. It's just a long way around to the answer. So if you'll keep in mind that you want to move this 9y over here instead of the 7y over there, then you will be in better shape when it comes to the end of this. So if you subtract your 9y from both sides, then you get negative 2y minus 3 is less than negative 4. And I chose to subtract the 9 because it's on, I need to get them on the left side, not the right side. Now add 3 to both sides, and I would have negative 2y is less than negative 1. Now I'm going to divide both sides by negative 2. When I do, it's going to flip that inequality. So don't forget that. That's going to become y is greater than positive 1/2. So in set notation, it's y such that y is greater than 1/2. On the graph, 1/2 would be somewhere there. Greater than would be parentheses because it doesn't have the bar underneath there. And the set that's greater are the numbers to the right. So now if I did it in interval notation, I would go left to right, and I would come to 1/2 first, and I would keep going forever. So that would be to infinity. And you always use the parentheses with infinity. Okay, now Eric, did you find your problem?
Yes, I did. It's going to be on tonight's homework for everybody who's paying attention. But it's division of fractions. It's negative 15 over 2 divided by negative 5/6.
Okay, we'll just cover this one tonight. And then when we get to it in our lecture, we won't have to worry about it. Negative 15/2 divided by negative 5/6. These are fractions. And the rule when you divide fractions is to multiply by the reciprocal. Okay, multiply by the reciprocal. What is the reciprocal? What is that?
It's the opposite.
5.
It's not really the opposite, because the opposite of negative 5/6 would be positive 5/6.
Well, I guess the inverse.
It's the inverse. That's a great word to use, inverse. So what you do is always it's the second number. It's never the first number. It's always the second number. That's the one you turn upside down. So the first number stays the same, 15/2, it's negative. The divided changes to a times, and I'm going to use a dot for times because we use x's so much in this course. And the second number will turn upside down. That's called the reciprocal. Okay? Now then, you can either multiply straight across 15 times 6 and 2 times 5, or you can do some cancellation if you want to. Those of you that have done this lots of times will choose the cancellation. Those of you that, and this is kind of new to you, will probably just multiply 15 times 6 and 2 times 5 and then reduce it. Let's do some canceling. 2 will go into 2 one time. I can cancel from any bottom to any top. 2 will go into 6 3 times. This is what I do when I'm multiplying both sides by that common denominator. In this one, I can do 5 will go into 5 one time, 5 will go into 15 3 times. Now, what I have is a negative 3 times a negative 3, which is a positive 9. And in the bottom, I have 1 times 1, which is 1. So that answer is just 9. 9 divided by 1 is 9. Okay, Eric, what did you do wrong on that problem?
I multiplied the top and the bottom, and then I reduced it.
Okay, well, what did you get when you multiplied the top?
When you multiply 6 times negative 15, you get negative 80.
No, not
multiply-
negative 80.
Or 80, sorry.
5 is 30. 6 times 6 is
Oh, wow.
3. So I think that would be 90, isn't it?
I'm sorry. I forgot how to multiply this afternoon.
And negative times a negative is a positive. So we could have 90 on the top that's positive and 10 on the bottom. 2
Yeah.
times 5 is 10. So what's 90 divided by 10?
9.
So multiplying is a problem, you know, so hopefully you'll remember your multiplication facts.
Yeah.
If not, you have a handy dandy calculator that will do it for you. All right, let's talk about our lesson tonight. And tonight we're going to get as far as we can get. I will do the lecture and then we will start doing the problems. I'll do the college algebra problems first, and then I will do the other ones. Let's see. Did Billy get on? Yes, Billy, you're here. I was worried about you getting back in. I see you, Billy. Okay, let's start our lecture with the 2.4. This is the lecture. Those of you that copied off the notes, I'll be following those notes. This is going to be on expressions that we're going to multiply and do some things that we've done before. So this one is very much like one that we did earlier tonight. And I want to go over it again because I know that some of you have some problems with these. This one does not need a common denominator because it already has one. If those 13s had been different, one of them been different, I would have had to find a common denominator. But I'm going to have to do that on this case because they're already common. But I do have to change that to a plus because of those two negatives there. So now what I have is negative 22/13 plus 5/13. Now then, because the signs are different, I would subtract the numerators and I would get a negative because 22 is larger, negative 17/13. And again, I do not change to a mixed number because in this course we don't do that. We leave them as improper fractions. All right, so the next kind that you're going to have, and some of you that do fractions, you know that you can do these on your calculator. I'll show you how to do this one in just a minute. But to do these by hand, you're going to need a common denominator. So I need something for 5 and 3. And this time I can't think bigger because 3 won't go into 5. But I need to think a bigger number, something that 3 would go into and 5 would go into. What larger number would that be?
15.
15.
15. All right, so if I choose 15 as my common denominator, how many times would 5 go into 15?
3.
3. So I'm going to take my 3/5 and multiply it by 3/3. That's called need over need. That's what I need to multiply by to get a 15 in the bottom. If I multiply 5 by 3 to get my 15 I have to multiply the top because this is really just a form of 1. And 1 times any number doesn't really change it. So that's how we can get away with doing that. Now let's do the second problem. 3 into 15 would go 5 times. So I need to multiply my negative 1/3 by 5/5. And that would give me my 15 in the denominator. And in the top, I'm going to have a 5. And there's a minus in front of it. So now I have negative 9/15 minus 5/15. This negative is going to kind of go with that as you combine those. And so now what I get is negative 14/15. Right, let's see if we can do this on the calculator. On the calculator, remember these are fractions. You probably want to use the parentheses. So I have parentheses, negative, and that's at the beginning. So I'm using this little negative sign down here. Negative 3 divided by 5 would give me my negative 3/5. Then I have a minus that connects the two fractions. So I'm using the minus on the side. And this time I put in 1/3. And again, I'm using a parentheses because it's a fraction. 1 divided by 3. Okay. Now when I hit enter, I get this lovely number, 0.933333333. So if I go to math, remember we did it earlier tonight, and I hit the first one that says fraction, I hit it twice, and it's going to convert that 0.93333 to negative 14/50. Isn't that cool? So you know you can use your calculator in your system. So if you're having trouble with fractions, don't hesitate to use your calculator. All right, number 3 on this one is multiplying fractions. When you multiply, you do not need a common denominator. That's something that people forget. So if I have negative 5/9 times 3/4, that little dot means times. And again, we don't use the X like you do in grade school for times, because we use X to represent a variable in our equation so much, so we don't usually do that between two fractions here. Now, you just multiply and you get negative 15/36. And then you've got to figure out if that will reduce. If there's something in the top and the bottom that's common. I can see that I could have canceled right here. The 3 into the 9 would have gone 3. So it must have a 3 in common. So let's divide out the 3. And we would get negative 5/12. If you do it on your calculator, you would have parentheses, negative down here at the bottom, 5 divided by 9. Remember that negative, if it starts at the beginning, it's the one down here at the bottom. Times, and you don't even have to put in times. You can just put the two parentheses close together, and that's the same thing as times. 3 divided by 4. And when you hit enter, you get a lovely little decimal number. So go to math, and you have fraction, enter, and it'll give you your negative 5/12.
Can I say something real quick?
Yes.
I was just going to say, if you have a new TI-84, most of them, if you hit alpha y equals, you'll get options to do like fractions and stuff if y'all want to do that instead of doing the division sign.
Really?
That's what I do.
I don't think that's on this one. That's on the plus, isn't it? Or I don't know if this one.
The one you have, Miss
Can't do that on
Sullivan.
yours.
You can all you gotta do is hit I think it's math, not math, but alpha and second, I think.
What did you say?
I did it.
Okay. What did you say it was?
Alpha y equals, but you said you had like that one for a while, so.
Yeah, it'll give you a little bitty box with all those
to do
options.
That. Sure does. That's a great idea.
I forget about the other way when you had the decimal, and then you go and you push something else. I forgot about that way. I just remember this way, the one that Luke said. Yeah.
And your My Lab has it this way. There's a selection down at the bottom of your problems that if you have to put in a fraction, it looks just like it does on your calculator there.
So I have a question really quick. So whenever we're doing like on our homework, should we presume that the answer should be in fraction form, or should we put it in decimal form, or does it matter?
Well, as Hunter, was it Hunter? Who was it that said today? Generally, if they give you fractions in your problem, that was Luke, wasn't it? Generally, if they give you fractions in your problem, they want you to have a fraction answer. If they give you decimals in your problem, they want a decimal answer. But now, whether or not if you put the decimal in instead of the fraction, if they will count it? I don't know the answer to that. I think it depends on the programmer that did that problem, if he clicked the point that said option for decimal. And if he did, then they will. If he didn't, they won't. That's pretty much, it's the programmer that did it, whether or not they.
I listened to Thomas and I knew that. I don't know. I think I'm half asleep right now.
Well, wake up, okay?
I'm doing my best.
We should do a dance or something in the middle. All right. Let's see what else we need to do. We talked about dividing fractions, how you turn them upside down already. Let's talk about dividing by 0. We already know that we cannot divide by 0. So if you have a 4 divided by 0, that 0's on the bottom, it's undefined. If you have a 0 on the top, you're okay. That answer's 0. But 0 on the bottom is undefined. So just remember that when you're doing these. Let's talk about multiplying with exponents. There's a problem like this on your homework. See how you've got x to the 3rd and x to the 4th there. And you've got these coefficients in front. So what you're going to do is multiply your coefficients. 2 times 3 is 6. Don't forget to multiply them. But then when you have exponents, this one is really x times x times x, and this was x times x times x times x. So how many of those little x's do you have all together?
7.
7. So you can say the rule is if you're multiplying variables that have different exponents and the variables are the same, then what you can do is add your exponents. If you can't remember that, then you can write it down and see how many you have all together. That'll work
On
as well.
dividing, you subtract, correct?
That is correct. Let's do one of those. Let's do 6x to the 10th divided by 2x to the 4th. If it's divided, divide your numbers, your coefficients, and you get 3. But what happens to these x's? Let's see, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the top, and 4 in the bottom. So if I canceled out the like ones, then 4 of these would cancel into 4 of these. And what would I have left?
6.
6. So x to the 6th would be what I had. If the 10 was on the bottom instead of the top, if I had 6x to the 4th over 2x to the 10th, I would still have a 3 when I divided my numbers. But what's going to happen when there's more x's on the bottom than there are on the top?
Negative.
You'll get a negative exponent.
You can get a negative exponent, but in our course, the question will say, leave your answer without negative exponents. So what you can do is do the same thing. Put your x's like this and cancel out. And you see that there are still x to the 6th, but where is that x to the 6th located?
In the denominator.
In the denominator. So to stay away from negative exponents, flip it and put the value of your x in the bottom with your positive exponent. And you can see if you subtracted 4 of these from 10 of these, there would be 6 of them left, but there's more in the bottom than in the top, so it ends up being in the bottom. Okay? We'll do some more of those. We'll have a whole section of those to do a little bit later. What if we had x to the 3rd plus 2 times x to the 2nd minus 3? Anybody remember what we did with those kinds of problems?
Distributed.
We distributed, but there was a special name they called it when it was
FOIL.
FOIL. First, outer, inner, last. Do you remember that? And it's the same thing as distributive. But you take the first ones and you multiply x cubed times x squared, and that's going to give you x to the
fifth.
Add your exponents. That's the first term here, first term here. Now you do the outer terms. We have x cubed times -3. That gives you -3x cubed. Now you have inner terms. 2 times x squared would give you 2x squared. And then you do last. 2 times -3 is -6. Now, if you can combine, you would combine them, but these will not combine, so that is your answer. X to the 5th is different from x to the 3rd, and that's different from x to the 2nd, and that's different from a number, which is called a constant, that doesn't have a variable with it. Okay, let's do the same idea, but let's change to functions because our course is about functions. If you had f of x equals x squared, that's a parabola, plus 3, and g of x, we have another function, equals x minus 5. Let's add, subtract, multiply, and divide them. Let's see. This thing is a parabola. This thing is a line. Are you okay with that? This is a parabola. This thing is a line. That's kind of important for you to know later on, not necessarily now. What's the domain of a parabola and a line?
Ms. Sullivan,
Yes?
are you do you continuously keep putting the poll back up? It keeps coming up on my screen like constantly.
The what?
The
The
poll that you sent out.
I don't know.
Does anybody else have an issue? No? Okay. It's just
Earlier.
me.
Let me see if I can X out of it and see if that does. Did that go off then? Did it go off for you?
Well, it hasn't shown back up since I said something, of course.
Just because you
so.
said something, Billy. Okay. Was that Billy that said that?
Yes.
Okay. Well, Billy, let me know if it does it again, and I'll try to get it off somehow.
Okay, no worries.
Okay, so we have a parabola and a line, and the domain is for both of these would be all real numbers. But we're going to add them first. Okay, we're going to do f plus g of x is the way it will look on your screen. And what that's going to tell you to do is take your f function, x squared plus 3, and add it to your g function, x minus 5. And then all you have to do after that is combine like terms. There's an x squared out there. There's an x. You usually put them in descending order. And then you can combine your 3 and your 5 to -2. And then it's going to ask you, what is the domain of your answer? Well, look at that. It's an x squared term. So this thing is a parabola. What is the domain of every parabola that's a function? And it's a function because you took 2 functions and added them.
All real numbers.
All real numbers.
All real numbers. So it's going to ask you for the domain. And then remember, they may have it in negative infinity to positive infinity. They may have the words written out, all real numbers. They might have x such that x is a real number. And they might even have the notation we used to use all the time, such that x is an element of the reals. And that's just a little cursive R there. Probably, let me see if I remember which way they did it. I think in this one they have this one. Now let's take the same 2 functions, and this time we're going to subtract. And you have to be careful when you subtract because you don't know if the F or the G is first unless you really pay attention, because they could say G minus F instead of F minus G. So be careful what they ask for. In this one, I'm just asking for F minus G of X. So I take the F function, which is X squared plus 3, and I'm going to subtract this time the G function, X minus 5. Now that minus sign in front of it, we've done a couple of these. That's going to change. It's like a -1 there, and it's going to change those values inside the parentheses. So I'll have an X squared plus 3 minus X plus 5. So now I have X squared minus X plus 8. That is a parabola because it has that X squared term. So my domain is all real numbers. Okay, now then, we're going to multiply them. I think I might have room to multiply them on here. We're going to say F times G. And by the way, one of them on your assignment says G times G. If it were G times G, you would take the X minus 5 and multiply it by the X minus 5. If it was the F times F, it would be X squared plus 3 times X squared plus 3. But this one says F times G of X, and it's multiplication. So that's equal to, my F function was X squared plus 3, and my G function is X minus 5. And when I multiply them, I'm doing first, outer, inner, last. Or I can distribute the X squared times each of these, and then the 3 times each of these. That's actually the same process. X squared times X to the first will give me X cubed. X squared times -5 is -5X squared. 3 times X is positive 3X. You're using the sign in front of the number and letter. And then a positive 3 times a -5 is a -15. Look at the leading exponent on this one. This is a cube. So this thing is a cubic function. What is the domain of a cubic function?
All real numbers.
Mm-hmm. So if in doubt and you on the test and you're not sure and it's asking for the domain, a good guess is all real numbers, because that's usually what it is. It's only not all real numbers when? When is it not all real numbers?
It's a rational function.
When it's
rational.
rational. That's correct. So I'm going to write my equation, my functions up here. And this time I'm going to divide, and it asked me to divide F divided by G. It could have asked me to divide G by F, could have asked me to divide G by G or F by F, but they don't usually do that because that's 1. So it's usually F divided by G in most of these. So we'll have X squared plus 3 on the top and X minus 5 on the bottom. And I see that it has a fraction at the bottom, so that thing is rational. So it's going to look something like this. It's going to be that split curve that rational functions have. And there is some place that is undefined. That happens every time. It's where that split is. Where is undefined for this problem? Do we know? What was our process?
The vertex.
We say that X minus 5 does not equal to what? We don't want it to equal to what?
0.
0.
So add your 5 to both sides and see what you don't want X to be. You don't want X to be 5. Now look at it. If I put 5 back there, what is 5 minus 5?
0.
So it makes sense. So this domain is all real numbers. except this one has an exception because it's rational. X does not equal to 5. Okay, so we can add, subtract, multiply, or divide these, and we can also put in any one of these, anywhere, we can make values using numbers. So suppose I want to find f of -4 minus g of -4. And I'm using the same functions, but this time I want to put some numbers in there. So I find f of -4 first. That means I'm going to put -4 in for x in the f function. So I have -4 squared plus 3 using my f function up here. I'm putting -4 in the x place. Now, -4 squared is positive 16 because -4 times -4 is positive 16. When I add 3, I get 19. Now then, let's find g of -4. G of -4, this is my g function over here. So I would have -4 minus 5. -4 minus 5 is -9. Now I follow my rule. In this particular one, I want to subtract the values. So I can do 19 minus a -9, which is 19 plus 9, which is 28. All right, so do you understand that you can add, subtract, multiply, or divide them, and you can even put numbers in them and do them with numbers? Any questions on that? Okay, I'm going to stop and take a break a minute, and we're going to go back to the webcam here and see if any of you are having difficulty. And I know that three or four of you, I think, they've already completed this. So those of you that have, what kind of problems did you see? Is there something we need to be aware of? Those of you that have gotten in there and looked at it, was there something you saw that you went, oh no, I don't know how to do that? We're going to work individually the problems until 8 o'clock. And at 8 o'clock, we'll stop and I will take individual questions. But before we do that, was there anybody that's already gotten into this that ran into something you thought, this is crazy, I don't know how to do that? Anybody? You know, this weekend I'm going to bug you. You do know that, don't you? So unless you have 100 in those little spots right there, you can probably expect a text from me this weekend to say, are you okay? Are you going to get this done? Do I need to help you? So this weekend, I don't have anything going on in my life. So it'd be a great time for you to call or text me, or we can Zoom. We can do an individual Zoom anytime we want to, and I can help you with whatever problem you're having. So anybody that's gotten in there that had problems with anything? Okay. Let me check this row really quick because y'all help me remember if people were on or not, if they've gotten off. Selena was there. Corey was there. Amanda was there. Margaret was there. Sashini was there. Astanika, are you here?
I'm here.
Okay, good. How about Morgan? Is Morgan here?
I'm here.
Okay, thanks, Morgan. Erica Early. Is Erica here? Deja was here. I saw her name. Kelly Hill. Is Kelly here? How about Lori Lawrence?
Here.
Thanks, Lori. Marlisha. Is Marlisha here?
I'm here.
Okay, Marlisha.
I'm here.
How about Brooke? Brooke was here earlier. Natalie?
I'm here.
Okay.
Natalie's here.
Okay, Tamala, did you make it in?
Yes, ma'am. I'm here.
Okay, thank you. I'm sorry about that. That happened at the beginning. It was my fault. My computer went crazy. Kiana Roberts.
I'm here.
Okay, how about Sequela? I know she was having trouble getting in too, but she's here. I see her. Luke is here.
I'm here.
Portia Stirred.
Here.
Okay. Korea Thomas. How about Donovan Tucker?
I'm here.
Okay. Eric Walker, I know, is here.
See.
Okay, Erica said that she is here. She's waiting on her laptop to reboot. Kiara, was Kiara here? He did mark Kiara here. Donovan's here. Eric's here. Braylon.
Yeah, I'm here.
How about Danielle Westbrook? I know she was here. I talked to her earlier. Chantel.
Here.
And Chandra.
Yes, I'm here.
And Billy Thompson. Billy, I see you. You're here. Okay, I'm just missing Kelly Hill, looks like, and Kiera. So if you see either of those names come up, let me know. All right, guys, I am going to start working on the assignments. That's what I'm going to do next. And I'm going to start with the college algebra one. So if you guys want to stay on board with me, you can. You're not required to because our time's up for your college algebra session. But for the next 30 minutes, I'll be working these individually. And these are just like the ones that you'll have in your My Labs. But the numbers are going to be different probably. You probably won't get the same numbers, but it will be the same kind of problem in the same order. Okay?
I was just give a tip to everyone in the college algebra part. Well, I guess
Okay.
everyone is, but at like the end of the homework, whatever it is, like 2.4,
Yeah.
when you get to like question 14 or something, it's gonna have a lot of words and stuff. You really just need to make sure that there's not a denominator. You don't have to like work it out or anything. Just look at it and make sure it doesn't have a denominator. Then you can answer it.
Mm-hmm. And your answer for those domains, if it doesn't have a denominator, is what?
All real
Real
numbers.
numbers.
Numbers, okay? That'll save you a lot of time if you'll remember that. Thank you, Luke. Anybody else have a hint? All right.
Also, make sure you put the X is not equal to whatever number that is, because I forgot to put the X on one of them, so I had to do a similar question just to redo it.
Mm-hmm. He's right. If you just put comma not equal to 4, it won't take it. It has to say X is not equal to 4. That's correct. So be sure you watch out for that.
Have a good night.
Okay, thanks, Luke. All right, let's do these 2.4. These are example problems like you're going to have in class in your My Labs. The first one is f of x equals x squared plus 2, and g of x equals x minus 1. So it's going to be similar to that. Let me switch my screens here. Somebody should have caught me.
I was trying to. I just didn't want to interrupt you.
That's okay, Brooke. And no, I don't teach A&P. Did you ask?
No, you don't. I wish you did.
Well, thank you. I appreciate that. But I've already had my stint at A&P 3 times. I had it with 2 girls, so I don't want to do it again.
What about me? You want to take a third?
I've probably forgotten how to do it by now. Okay, this one says find f plus g, and it says of x. So we're not putting in a number, we're just adding them together. So f is x squared plus 2, and I usually put a parentheses around the 2 functions as I'm putting them in this form, because when it's a minus, you're going to have to change the signs. But when it's a plus, you don't have to change signs. So now then I just add those together. I don't have to worry about the plus changing my signs in the second parentheses, and I try to put them in order with my x squared, then my x, and then this positive 2 and negative 2 is going to combine together. Notice these are not multiplied, these are added. And you get positive 2 minus 1 is positive 1. That is a parabola. It didn't ask me on this problem what the domain is, but the domain is all real numbers. In the second one, they give you another one, f of x equals x squared minus 3, and g of x equals x minus 4. And they want you to multiply them this time, f times g of x. So you put your x squared minus 3 in one parentheses and your x minus 4 in the other one for your g. And each time they'll change your function, so get ready for that. Your functions will change all the time. Now this is where I want to do full. So I have x squared times x is x cubed. X squared times negative 4 is negative 4x squared. Negative 3 times x is negative 3x. And be careful on your signs. Negative 3 times negative 4 is positive 12. And I can't do anything combining on that, but I see that it's a cubic. So my answer for the domain, if they ask me, would be all real numbers. Number 3, again, they've changed their functions. You have x squared minus 3, which is a parabola. And g of x is x plus 1, which is a line. And this time, they want us to find g times g of x. They aren't even using the f. They just wrote it down to see if you get confused, I guess. So we're going to take the g, the x plus 1.
Does it say x cubed or x squared? I can't see it.
I'm sorry, it says x squared, but thank you.
Oh, okay. I thought it said cubed. Okay, thanks.
But since we didn't use the f anyway, I guess it doesn't matter. But we're only using the x plus 1 because it says g times g. You see that? So watch out for that because you'll miss that. You'll miss it on the test too because they do it on the test. Now we have to foil this. So we have x times x is x squared. X times 1 is 1x. 1 times x is 1x. And 1 times 1 is 1. So this one's a little different from number 2 because there are two things with x's in the middle that we could combine. So before I leave it, I'll have to change that to x squared plus 2x because 1x and 1x is 2x. Plus
the like terms.
Those are called combining like terms. Very good. Who said that?
Me, Chandra. I just remembered it because I forgot when you FOIL, if it's the same, if it's basically the same, if it's got the same
variable.
Yes, variable. Then yeah, you add it.
And that's called combining like terms. Very good. Very, very good. All right, let's try this one. This one has two different functions. Of course, they change the function every time. It would make life a lot easier if they just leave the functions alone. This one now is a line. See, it's to the first power. So that's a line. And g of x in this case is x squared plus 19. That's a parabola. But this time, they want us to find f of negative 10 plus g of negative 10. Now, those of you that know a lot about mathematics know there's 2 or 3 ways you can do these. But this is the way I do it because I think it's easier to explain and easier for you to remember. I find each one of them. I find f of negative 10 by putting negative 10 in my x spot on the f function. So now it's going to say negative 19 times negative 10 plus 3. And all I did was put that negative 10 in that x place in the f function. Now, negative 19 times negative 10, a negative times a negative is a positive. And if I'm not mistaken, 190 will be the answer. Plus 3. So I get 193. And that's just for this part over here. 193. That's what my f of 10 looks like. Negative 10. Now I'm going to find g of negative 10. So I'm not going to use the f function, I'm going to use the g function. So I put in negative 10 in a parentheses and square it. You will find out your life will be easier if every time you substitute values in, you put them in a parentheses. That will help you tremendously down the road. Negative 10 squared would be negative 10 times negative 10, which would be positive 100, plus 19 is 119. So bless you. I'm going to substitute back up here.
Thank you.
For 119. And notice my plus is that plus that's right there. So I'm just going to add those two together, the 193 and the 119. And I think, let's see, 9 and 3 is 12, 10, 11, 3. Looks like I get 312. Did anyone else get 312?
Yes, ma'am.
Okay, good. All right, do you see what I did? I put the 10 in for the F and the 10 in for the F, the G, and then I added them together. Okay, any questions? Let's go to 5. Number 5 says, let f of x equal negative 12x plus 17, and g of x equals x squared plus 18. Now this one they want us to find f of negative 4 minus g of negative 4.
Can you scoot the paper down a little bit? We can't see this.
How's that? Is that better?
Okay, thank you.
All right, so I'm going to come over here and find f of negative 4, which is negative 12, and then I put a negative 4 in there where x was, plus 17. Notice I'm using the f function. Negative 12 times negative 4 is positive 48, plus 17. And 48 plus 17 is 65. Is that correct? So I'm going to put the 65 here and come over here under f of negative 4 and put 65. Now I'm going to find g of negative 4. That would be negative 4 squared plus 18. Negative 4 squared is negative 4 times negative 4, which is positive 16, plus 18. And let's see, 16 plus 18 is 34. So I'm going to put my 34 in here, this g. Now notice this one's not plus, this one's minus. So what I'm doing is subtracting the 65 and 34. And I think that is 31. So there's my answer. Okay, let's look at number 6. Of course, we have new functions. F of x equals negative 20x plus 16. G of x equals x squared plus 19. This time they want us to find f of negative 3 times g of negative 3. They don't always have to be the same number, but most of the time they are. It gets a little complicated if you don't use the same number algebraically. All right, so f of negative 3 would be negative 20 times negative 3 plus 16. Negative 20 times negative 3 is positive 60 plus 16, which is positive 76. Come over here and put my 76 under there. G of negative 3 equals negative 3 squared plus 19. That would be 9 plus 19, which is, if I'm not mistaken, 28. So I'll put my 28 under the G. And this time I'm going to multiply. So somebody multiply 76 times 28 for me and see what you get.
2128.
Look at that. You've already done this ahead of me. 2128. Okay. Number 7. Number 7 said f of x equals negative 19x plus 14. And g of x equals x squared plus 4. This time they want us to find f of negative 4 divided by g of negative 4. So f of negative 4 is negative 19 times negative 4 plus 14. I think that's positive 76 plus 14, which is 90. G of negative 4, and I will put this 90 over here, by the way. G of negative 4 is negative 4 squared plus 4, which will give me 16 plus 4, which looks like 20. So I have 90 over 20. And if you put that answer in, they're not going to count it right. Why not?
You have to simplify it.
You have to simplify. 90 over 20, you can divide them both by 10. And what do you get?
9 over 2.
That's correct. Right. Anybody have any questions about 5, 6, or 7 before we go on? Any questions? All right. Let's keep going. These are the harder of the two assignments. The assignment for the support is not very hard. It's mostly fractions that you add, subtract, multiply, or divide. Hopefully that won't be hard for you guys. This number 8 is let f of x equal negative 2x plus 5, and g of x equals x squared plus 3. Notice how very often one of them is a line and one of them is a parabola. They like to do that. They like to put those two together. This time, they're going to do f plus g of x. So there's no number to substitute in. So I just take my f function, negative 2x plus 5, and add my g function, which is x squared plus 3. And I want to combine the like terms and put them in descending order so that the top exponent, the highest exponent, is at the top. So this would be x squared, because I would use this one first, minus 2x. And then I would take that 5 and that 3 and I would combine them to make 8. And that is a parabola. So that answer for domain would be all real numbers if they asked it, but they didn't ask it. Okay, number 9, they changed functions. F of x equals 9x minus 6, and g of x equals x squared minus 2. And they want us to find on this oops, sorry, I skipped across. Sorry. 9x minus 6 and 2x minus 4 for g. I skipped to the next one. This time they want us to do f minus g of x. So be careful when you're doing the minuses because it's going to change the signs on the second function. So you'll have a 9x minus 6 is your f, minus g is 2x minus 4. And so now I have 9x minus 6 minus 2x plus 4. That right there will be the mistake. If you make a mistake, you'll forget to distribute that negative times that negative. So be careful there. Now there's some things we can combine. 9x minus 2x is 7x. And a negative 6 and a positive 4 would be a negative 2. Okay, number 10. You have f of x equals negative 3x plus 5, and g of x equals x squared minus 2. This is the one I accidentally put up there last time. This time they're going to turn it around backwards, and they're going to make it f minus g of x. And they can, g minus f of x. They can do that. They can pick whichever one they want to put first. So we're going to pick up the g first, x squared minus 2, minus, because we're subtracting, negative 3x plus 5. Now I have to be careful on this, these two negatives there. So that's going to be x squared minus 2. This one doesn't change. But this one, as you distribute that negative 1 across there, is going to become positive 3x minus 5. So be careful with that. And now to put them in decreasing order or descending order, we have x squared plus 3x minus 7 for our answer, which is a parabola, so the domain would be all real numbers. Number 11, f of x, and notice they used a capital F, and it's okay, but usually when they use a capital F, they'll use a capital G. They can name it anything they want to with any letter. So we have x squared minus 2 is the f function, and g is 12 minus x. By the way, this g is 12 minus x, which is a line, but see how that minus is on that x? Instead of my line going this way, which it normally does, that minus in front of that x is going to make that line slant the other way. It's going to go downhill because it has a negative slope. That's just something added for your money. You don't have to know that yet. F minus g of negative 9 is what they want. So we're going to find f of negative 9 first, and that's negative 9 squared minus 2, which is 81 minus 2. And 81 minus 2 is, which is 81 minus 2? 79. So this is 79, and g of negative 9 is 12 minus a negative 9, which is 12 plus 9, which is 21. So 79 minus 21 is 58. How's that? Now, because of the way it's written, you could subtract these first and then put your answer, the 9, in the 2 that's into the answer. And that would be fine. That works. So you can do it that way as well. Just be careful on those. Number 12. Number 12 is f of x equals x squared minus 11. And g of x equals 18 minus x. This time they're going to do f times g of a. Of a, that's interesting. There's no number for us to put in, but there's a letter for us to put in. So instead of x, we're going to put in a. So this is going to say a squared minus 11 times 18 minus a. And so just like substituting a number, we're going to substitute in a letter. So now then,
So you just do the FOIL method after that, correct?
That's correct. You are correct. Very good. So we have 18a squared when I do the first ones. The outer one's going to give us a to the first times a to the second is a to the third. The inner ones are negative 11 times 18, and I think that is negative 198. Somebody check and make sure I haven't done that incorrectly.
It is.
And then last is positive 11a. Thank you. Now, the only thing I'll have to be careful because I don't think your author will take it if you put it like that. You can try it, but I don't think he'll take it. I think you've got to have that negative a cubed first plus 18a squared plus 11a minus 198. Has anyone done this problem?
I haven't done it, but I remember in the past that you do gotta rewrite it. And, you know, from the biggest exponent to the smallest here.
Well, somebody that's brave, when you get to this one and you do the problem that's there, try putting it in the wrong way and see if it takes it. See if they'll give you the, see if it lets you take it with it out of order. Or if this author makes you put it into to the right order. Somebody do that for me and let me know.
I have a question.
Uh-huh.
Sure, I'm not crazy. You only use the FOIL method when you multiply, right?
Right.
Okay, thank you.
You're welcome. You're not crazy.
Oh, yes, I am.
I know on number 11, I kind of got confused because when you said, I mean, I guess it's kind of easy if we put in the F minus G in parentheses, and then we put the, was that A or 9?
9. That's a 9.
Yeah, so that would have made me think to multiply all that.
What made you think to multiply it? Because of the way
Putting the 9 in the parentheses, yes. Because at first, when you was writing it down, I was like, what? But then I remember you said you can put it in parentheses. Yeah.
See, this
that's where, yeah.
X, that's the same. We just put it subtracted. And what I was saying is that you can subtract these functions first. X squared minus 2 times 12 minus x and get, I'm not times, but subtracting 12 minus x. And you get x squared minus 2 minus 12 plus x. And that's a minus in the between there. And if you put in your negative 9 here and your negative 9 here, I think you'll get 58. So that would be 81 minus 2 minus 12 minus 9. Isn't that still 58? I think it
81 minus 2 minus 12 minus 9. Yes.
So you can do them separately, or you can just subtract the two functions first and then put in your number. And actually, you can do that in any of them. You could, in this one up here, you could have added, oh, that's not if you had a number to go in there. Any of them, you can do the operation first and then put in the number if you want to.
Miss Sullivan.
Mhm.
So on that question that you just did, if you put it in wrong, it'll pop up and tell you that your answer is equal to the correct answer, but it's not in the correct form. It has to be in descending order.
Yeah.
Okay, well, good. So now we know the answer to that. I didn't think they would let us do it without putting it in the descending. Sometimes they call it descending, and sometimes they call it another name. But it means you got to go down. You start with the top one, and then you go down. This one's going to be good because this is the first one we've had that's a divided by that's on this section of our problems. So we want to put in -4, but we want to divide them. So let's put in -4, and we get -4 squared minus 20 would be 16 minus 20, which is -4. That's interesting. So -4 goes on the top. Let's see what goes on the bottom. G of -4 is 1 minus a -4, which is 1 plus 4, which is 5. So it looks like it's going to be -4/5. Well, that wasn't exciting. That was too easy. Okay, the next section, we're on.
Oh, can you, I was just gonna finish writing it. I'm almost finished.
Okay, all right. Tell me when you're finished. I want to do one more with the group, and then we'll do individual questions. Let's see, 14, 15 is...
Okay.
Got it?
Miss
Yes.
Sullivan, I meant to ask, how many questions are on the test?
25, I think. I will look again. I meant to look before. I looked on the quiz and it has 25, and I think always the quizzes and the test have the same number. But send me a text and I'll remember to double check this week. And the quiz questions are just like the test questions. So you want to do a really good score on the quiz so that you know what's coming on the test and that you're going to be able to do it all. Okay, I'm going to do one more and then we'll talk about individual questions that you guys have. I'm going to skip over and do number 15. 15 says determine the domain of the sum, difference, and product. Doesn't say divided by, it just says sum, difference, and product. But in our problem, we have a rational function as one of our functions. So that's kind of a cool little thing there. Okay, so let's do sum. F plus g of x is going to be 1 over x minus 7 plus 3x cubed. Now, don't go to the trouble of finding out how to combine that and add those together. You don't have to do that because the problem just asked for the domain. It didn't ask for anything else. Well, this little cubic part of it, the domain is all real numbers. But when I add it to this part, then what I've got is the whole thing I have to consider. And because this part is one of those rational functions, remember, those little split things, because it has a denominator, there's a place that's not defined. So when I add these together, I've got to consider that fraction. So I'm going to take that denominator and set it not equal to 0. So my x is not equal to 7 when I add 7 to both sides. So when I write my domain, I'm going to say I think it might be in set notation form. X is a real number. You have to have that part. And as Luke was saying, it'll have a comma there, but you have to put this X in there. X not equal to 7. You have to put that whole part in there. If you just put not equal to 7, it will not count it for you. So you have to put the X in. There's a little box there. You have to put the X in that little box. If you don't put X and you just put not equal to 7, won't take it. Okay, the difference, F minus G of X. Well, when we write them down, again, the only difference is that it says minus X, 3X cubed. So I've got the same thing. The only thing I have to worry about is that fraction that's there. And that fraction is going to mess me up. I have to remember that I have an exception. X is a real number, but X cannot equal 7. The problem hasn't changed. The X still can't be 7. And when I multiply them, I have the same thing. That would actually be, if I wanted to do something else, 3x cubed over x minus 7. I still can't do anything else because I've just got this denominator that I've got to deal with. That denominator messes everything up. It makes it one of those rational functions. And I have to say that it's got to avoid that 7. X is a real number, comma, X does not equal to 7, and you do have to put all of that in the box.